This is a new video for differential equations, and in that video I'm going to talk about some examples so that you can easily calculate the CF. Now in that case we have to calculate the CF. You can see this is the differential equation and this is a homogeneous differential equation because there is no independent function of x and something like that. So however, this is a homogeneous equation and we have to calculate the CF only because the solution is equals to YCF. So you have to calculate YCF. The procedure I have told you in the previous video. So I am following the procedure, which is nothing but this is d square plus what? This is k square into y is equals to 0. So we have to calculate the roots of this polynomial where d is the variable. So d square plus k square is equals to 0. So from that we can easily calculate the value of d, which is nothing but plus minus I k. In some of the books you will see it is not I, it is plus minus j k. And why it is j? Because in some of the cases we will use current, the symbol of current as I, that's why we are replacing the iota as j. Okay, so not an issue I guess. So however, in that case d is our kind of complex number, right? So what will be the value of ICF? So the value of ICF will be what? E to the power alpha x, and point to be noted, e to the power alpha x into c1 cos kx plus sine this is c2 sine kx. Now in that case basically the alpha or the real part will be 0 because it is a kind of imaginary number. The real part is 0, so alpha will be 0 and it will be like e to the power 0 and it will be 1. So I am replacing this part, or you can see I am erasing this part. So however, you can understand. Now we are using the initial conditions. In that case this is the initial condition because t is not mentioned. This is a kind of variable where you can see the displacement vectors or quadrant or whatever you want to say. So y and x. So now basically the value of y is 0 when x is 0. So basically this is our YCF, which is also equals to our y, which is nothing but our solution actually. So y is equals to what? We have to find out the value of c1 and c2 from the initial conditions. So this is our c1 and I am replacing y as 0, right? Because we are replacing x as 0. So this is cos 0 and value of cos 0 is c1 into 1, which is c1, plus sin 0 is 0. So our c1 is 0, right? So our c1 is 0. Very nice. Our first solution is c1, which is 0. Now let's talk about c2. Now when x is equals to a, then y is also 0. So this will be 0. This will be 0 is equals to what? c1 into cos a ka actually plus c2 into sin ka. Now point to be noted, c1 is 0, so our c2 into sin ka is equals to 0, right? Now some people will say our c2 is 0 and some people will say no, our c2 is not 0. The actual answer is c2 will not be 0 because if c2 is equals to 0, then YCF, or you can say y, or the solution of this differential equation will become 0, which is not possible. 0 is this, like 0 is the solution for every differential equation, every this kind of differential equations, homogeneous differential equations, because you know what I mean. So however, hopefully you can understand what I want to say. So c2 not equals to 0, so definitely sin ka is equals to 0. Now I am using the generalized version of this term, which is known as ka is equals to what? N pi. Don't write like pi or 2 pi because we are generalizing this. So this will be k is equals to n pi by a. Now we have to just replace so that we can get the actual answer. We have to just replace the value of c1, or you can say the value of c2, or you can say the value of k also, because we have already found the value of k. So y would be equal to c1 into cos x. Now c1 is 0, so we are writing 0 into something is 0, right? This is c2 we don't know the value of c2, so c2 not equals to 0. We know that c2 not equals to 0, but somehow the solution will become 0. So this is the only possibility, right? Hopefully you can understand, and this is our final solution. You can erase the 0 from here, and you can say this is our final solution. This is our final solution. Hopefully you can understand very easily. You can solve this kind of questions. Now let's talk about another problem. Wait, well, this is our new problem, and in that case our y is equals to nx. So for clarification I am replacing nx as y, and definitely this is our definitely this is our homogeneous equation, because there is no function of x. I am talking about independent function, be careful, no function of x which is independent, right? Now basically independent in the sense y, the function of y or y is not multiplied with the function of x. Hopefully you can understand. Now in that case our y's will be nx is equals to cf, right? We have to find out the cf, not classic actually, complementary function. So nx will be equal to our ycf, so we have to solve. Now basically this is our d square minus 1 by l square into nx, which is y, I am replacing nx as y, is equals to 0. Now we have to solve this polynomial for getting the value of ycf. Very nice. Now d will be equal to what? Our plus minus l, I guess, sorry, 1 by l. Very nice. Now according to the formula, ycf will be equal to what? Now this will be equal to what? According to the formula, c1 e to the power minus sorry, not minus, I am writing the plus first, the first root first actually. So plus c2 e to the power minus x by l, right? Hopefully you can understand. Now this is our nx also. Now we are using the boundary condition, point to be noted, where you have to find out the cf. Then after finding out the cf, you have to use the boundary condition or initial condition. In case of pf, not pf actually, pi, particular integral, in that case you have to calculate the cf, then you have to calculate the pi or particular integral, then you have to add both of them and you will get a final solution. Then you can use the initial or boundary condition. Without that, after finding out the cf you can't use, after finding out the pi you can't use. You have to find out both of them, and then you have to add both of them, and then you can use the initial and boundary condition. Otherwise you will get an answer which is not correct. So hopefully you can understand. Now I am using the boundary condition. In that case it is boundary condition because t is not mentioned, it is not an initial condition. Hopefully you can understand. Now what is the boundary condition? Boundary condition is when x is equals to 0, nx will be k. Very nice. Now this will be our k is equals to, k will be equals to c1, x is 0, so this will be c1 plus c2, right? X is 0, so this will be like e to the power 0 and it is e to the minus 0. So c1 plus c2 is k. Nice. Now next condition is when x is equals to infinity, then our nx is equals to 0. Very nice. Again our nx is 0 is equals to c1 e to the power infinity plus c2 e to the power minus infinity. Now from that we can easily say that e to the power infinity not equals to 0, and I'm not writing the and, this is equals to 0, right? So you can say c1 is 0. Just solve the equation. This part will be 0 and this part will be 0 again according to the equation. This part will be 0 because of this is e to the power minus infinity, which is 1 by infinity. 1 by infinity is 0, and this is our c1 into e to the power infinity. So e to the power infinity will not be equals to 0, so c1 is 0. Very nice. Now our c1 is 0, so c2 is k. Very nice. Very nice. You can understand. You can easily find out the solution of c1 and c2. The values of c1 and c2. Now ycf, not ycf, it is actually nx, right? Nx is equals to what? c1 is 0, nx is what? This part will be 0, this part will be 0 because c1 is 0, but this part will not be 0. So basically I'm not writing the first part, I'm writing the second part. C2 into C2 is k and e to the power minus x divided by L. Now this is our final solution. Hopefully you can understand the procedure and you can easily solve this kind of questions. So in the next video I will talk about some more examples where you need to like calculate the d, and it is too much difficult. Sometimes you have to use the vanishing method, like you will see d to the power 4. In that case you have to use the vanishing method. It depends actually. In the next video I will talk about some more examples so that you can understand it more carefully and you can solve it easily. Point to be noted, these are very easy questions, and in exams you will see maybe like you will see maybe this kind of questions, because examiner will try to confuse you and he or she will provide a kind of a function of x which is independent, or a constant which is also a function of x where x is 0 or something like that. X is 0 in the sense I want to say like x to the power 0, the degree is 0, or the order, whatever you want to say. So hopefully you can understand, and you have to calculate the pi, and after calculating pi you have to calculate the CF, or you can calculate the CF at the first. However, it doesn't matter actually, but after calculating CF and pi you have to add both of them. Then you have to use the initial and boundary condition, and at the end of that you will get the answer, which is a very long procedure, and you will take around 10 minutes to 15 minutes, and the question is around 5 marks or 6 marks, which is very lengthy question. So be careful when you are solving any kind of questions like where you have to calculate the CF and PI. The questions will be very lengthy, so be careful when you are calculating. Calculation mistake will be there and it will be done by you, and even if it will not be done by you, it will take a very long time, so be careful. In the next video I will talk about some more questions in CF, and after that I will talk about PI calculation is too much hard. I mean it is conceptual actually, not hard. It is conceptual. If you know the concepts then it's okay, otherwise you can't calculate. Just in simple words I can say you can't calculate if you don't know the procedure. So be careful when you are calculating PI. In the upcoming videos I will talk about PI, so be careful. Okay, goodbye.